Good day, madam. My name is Chui Yee, matric number S54413, and my FYP title is a review of synthesis, properties, and biological applications of hybrid trimetallic alloy nanoparticles. COVID-19 is also known as severe acute respiratory syndrome coronavirus 2, and due to the COVID-19, a video is needed to present the FYP. Problem statement 1. Small size of nanoparticles are toxic to human and environment due to their shape, size, and low stability. Small size of nanoparticle can penetrate to the body through lungs and human skin. Problem statement 2. Monometallic and bimetallic nanoparticles have less stability. SERS is a technique to detect the possible biomolecules responsible for attachment to nanosite precursor for noble metals such as silver, copper, and gold. SERS measurement helps us to understand the stability of nanoparticles. For example, silver copper is bimetallic less stable, and the addition of the gold can increase the SERS efficiency and yield a stable trimetallic nanoparticles. The synthesis of TMP is important to produce a more stable and active SERS substrate. TMPs are more stable and active SERS substrate. So the demand of TMPs is increased rapidly due to their performance is better than bimetallic and monometallic nanoparticles. BMP and TMPs are widely reported due to their improved electrochemical and catalytic properties. TMPs are used as substrate in SERS. For example, colloidal trimetallic nanocomposites, porous trimetallic nanogauge, and trimetallic nanocomposites are used in SERS measurement of rhodium-3b, L-cytosine, and 7-aza-indole respectively. So the trimetallic nanoparticles offer the computer advantages over monometal and bimetal. Thus, the demand of TMP is increased in the world. This is due to TMP are stable and pose less toxic. The objective of the review is to determine the properties of the hybrid alloy nanoparticle, and the second is to learn the importance of the synthesis of hybrid trimetallic nanoparticle, and the third is to identify the biological application of the hybrid trimetallic alloy nanoparticles, and the fourth is to understand the effect of the nanoparticle to the environment and human bodies. How to synthesize the trimetallic nanoparticles? There is 6 methods, and the first method is sputtering. So the plasma consists of positively charged argon ion and free electrons, whereas the plasma target is negatively charged. So the argon ions are extracted towards its surface, and the argon ions collide with the target and eject the molybdenum atoms from its surface, and this is called sputtering. And the nanoparticles are deposited into the glass substrate. Then the second method is laser ablation synthesis. So for laser ablation synthesis, the nanoparticles are generated by nucleations and growth of laser vaporizer species background gas. The extremely rapid quenching vapor is advantageous in producing the high purity nanoparticles in the quantum size range, which is less than 10 nanometer. And the third method is the mechanical milling. So for the mechanical milling, it is used to generate the amorphous and the nanocrystalline alloy nanomaterials by milling and the post-annealing of the composite powders in the atmosphere. And the purpose of the milling is to reduce the size of the particle and to mix the particle in the new phase. The fourth method is the chemical precipitate-based nanoparticle synthesis, and the nanoparticle are synthesized via precipitation from the solution, and the method is one-step process and is suitable for the large-scale nanoparticle productions. And the fifth method is the chemical reductions, and the chemical reduction is carried out sequentially, and we can see that the silver ions is from the cluster and from the nanoparticle in the one step. And then is the sixth method is the electrochemical process. The electric field is generated by the two electrodes, and the reduction reaction takes place at the metallic anodes or with the anode in the solution together with the metal precursor. And finally, the new metallic nanoparticles are formed at the cathode. And next, due to the properties of the trimetallic nanoparticles, such as optical catalytic photocatalytic, TMPs can be used in a variety of the biological applications. For example, first application is the imaging. And the second application is the antimicrobial activities. And the third application is the diagnosis for catalyst and sensor. Fourth method is the drug delivery and the cancer therapy. And the last, fifth application is the potential vaccine adjuvant for therapy. In summary, TMPs are priority to use to produce the biological application since it is a more stable nanoparticles and an active SERS substrate. The improvement in the existing properties is expected to bring an excellent benefits in the future in the use of alloy trimetallic nanoparticles. And the limitation of the review is the authenticity of the review is limited because immunorebel experiments are needed to prove its authenticity and accuracy.